Hello viewers, in today's class we are going to discuss one important definite integral involving greatest integer function, right? So here we have to evaluate this integral from 0 to 2 x raised to greatest integer x square, right? So here we have the greatest integer function, and that is greatest integer x square. So let us start. So let us first call this integral as I, right? Now here we will make use of the method of substitution, and let us put u is equal to x square, right? So when u is equal to x square, then x is equal to square root of u, right? Now therefore dx over du is the half square root of u, right? And dx is equal to du over 2 times square root of u, right? Okay, now here we'll change the limits, because here x varies from 0 to 2, and we are changing the variable x to u, right? So when x is 0, then u is 0 square. Here we'll put x equal to 0, so this is 0, and when x is 2, u is 2 square, that is 4, right? So now this integral I can be written as integral from u is equal to 0 to 4, and for x we have square root of u, and to the power, here we have greatest integer u, right? Because x square is equal to u, and for dx we can write du over 2 times square root of u, right? And here we see that this square root of u raised to 1, here the power is 1, and here the power is greatest integer u. So now this integral can also be written as 0 to 4, and we have square root of u raised to greatest integer u minus 1, right? And we can take this to outside the integral, right? So here we have used the properties of exponent, that is a raised to b over a raised to c is a raised to b minus c, right? So now let us look at these limits, that is the lower limit and the upper limit. So here the lower limit is 0 and the upper limit is 4, right? And u varies from 0 to 4, and here we see that our integrand, it involves the greatest integer function, right? And therefore what we will do, will split this integral, right? So between 0 and 4 we have the integers 1, 2 and 3, right? So now we have to split this integral I into 4 integrals. The first one is from 0 to 1, the second one is from 1 to 2, the third one is from 2 to 3, and the fourth one is from 3 to 4, right? So now this integral I can be written as a sum of 4 integrals, right? I1, I2, I3 and I4, right? And we will solve these 4 integrals individually or separately, right? So now I1 is from 0 to 1, right? So these are the two integral points or the integer points. So we have half, and we have 0 to 1, and here we have square root of u and greatest integer u minus 1 du. Here du is also present, and here also we have du, right? So now here we see that u varies from 0 to 1, and when u varies from 0 to 1, then the value of greatest integer u is equal to 0, right? Okay, so now this integral I1 takes the form half 0 to 1, then we have square root of u, and the value of greatest integer u is 0, so we have 0 minus 1 du, and this is half 0 to 1, and we have u raised to minus half, right? Because this is u raised to half, and u raised to half times minus 1 is u raised to minus half du, and this is half, and the integral of u raised to minus half is minus half plus 1. Here we have minus half plus 1. Limits are from 0 to 1. We have half, and this is u raised to half, and this is half, and 0 to 1, half and half get cancelled, so we have u raised to half, and limits are from 0 to 1, so we have 1 raised to half minus 0 raised to half, that is 1 minus 0, that is 1, right? So the value of this integral I1 is equal to 1, right? Now let us calculate the value of I2. So now I2 varies from 1 to 2, so we can write half and 1 to 2 square root of u, and greatest integer u minus 1 du, right? And here we see that u varies from 1 to 2, right? And when u varies from 1 to 2, then the value of greatest integer u is equal to 1, right? So when u lies between 1 and 2, then then due to the definition of greatest integer function, the value of greatest integer u is equal to 1. So here I2 is equal to half 1 to 2, this is a square root of u, and this is 1 minus 1, so here we'll take 1, and this is du, this is half 1 to 2, and this is a square root of u raised to 0, and this is 1, and we have simply du, right? And the integral of du is u, limits are from 1 to 2, and we have half 2 minus 1, this is half times 1, that is half, right? So I2 is equal to half, right? Okay, now let us calculate I3. So now I3 is from 2 to 3, so we have half, u is equal to 2 to 3, and here we have a square root of u raised to greatest integer u minus 1 du, right? Okay, now here we see that the value of u varies from 2 to 3, and from the definition of greatest integer function, the value of greatest integer u is equal to 2, right? So here we'll take 2, so I3 is equal to half 2 to 3, here we have square root of u, and this is 2 minus 1 du, and here we have half, and we have 2 to 3, and we have simply square root of u raised to 1, that is u raised to half du, right? And the integral of u raised to half is 3 by u raised to 3 by 2 over 3 by 2, and limits are from 2 to 3, and now we have half, and this is 2 by 3, and here we have u raised to 3 by 2, limits are from 2 to 3. 2 and 2 get cancelled, so we have 1 over 3, and here we'll take the limits and we'll take the difference. So this is 3 raised to 3 by 2 minus 2 raised to 3 by 2, right? So the value of I3 is equal to 1 over 3 raised to 3 by 2 minus 2 raised to 3 by 2, right? Now let us calculate the last integral, that is I4. Now viewers, I4 varies from 3 to 4, so we have half, and we have u is equal to 3 to 4, and here we have square root of u and greatest integer u minus 1 du, right? And here u varies from 3 to 4, so now we have the value of greatest integer u is equal to 3, right? Because when u lies between 3 and 4, by definition of greatest integer function, the value of greatest integer u is equal to 3, right? So now here we'll put greatest integer u is equal to 3. So I4 is half, and integral from 3 to 4, here we have square root of u, and here we have 3 minus 1 du, right? And now we have half 3 to 4, and here we have u raised to half square root of u, and this is 3 minus 1 2 du. 2 and 2 get cancelled, we have half 3 to 4 and u raised to 1 du, right? And the integral of u raised to 1 is u square over 2, and the limits are from 3 to 4, right? So now we have we can take this to outside, so we have 1 over 4, and here we have u square, limits are from 3 to 4, we have 1 over 4, we have 4 square minus 3 square, and this is 1 over 4, 16 minus 9, that is 1 over 4 times 7, and this is 7 over 4, right? So the value of I4 is equal to 7 over 4, right? So viewers, this integral I, we have broken this integral I into 4 integrals from 0 to 1, 1 to 2, 2 to 3, and 3 to 4, and the values of the 4 integrals are written over here, right? Now the value of this integral I is the sum of these 4 integrals. So now I can be written as I1 is 1 plus I2 is 1 over 2, I3 is 1 over 3, 3 raised to 3 by 2 minus 2 raised to 3 by 2, and I4 is 7 over 4, right? So now I is 1 plus half is 3 over 2, and here we have plus 7 over 4, and the sum of this these two terms and this one is LCM is 4 here, so we have 6 plus 7, that is 13 over 4, right? So here we have 13 over 4 plus we can multiply these two terms by 1 over 3, so we have 3 raised to 3 over 2, here the power is 1, so we have minus 1 minus 1 over 3 times 2 raised to 3 over 2, right? So I is 13 over 4 plus this is 3 by 2 minus 1 is half, and 3 raised to half can be written as square root of 3. So here we have square root of 3 minus 2 raised to 3 over 2 over 3, and this is the required value of this integral, right? So viewers, this is how we solve this integral involving greatest integer function.